Top-down design. Break down into smaller and smaller pieces, easy to implement. Bottom-up design. Uses pre-existing modules libraries, saves time and effort. Object-oriented programming. Interacting objects, data-centered, bundles actions and processes with data. Very large projects can be developed more easily, modifications can be made without altering the insides. 3 big ideas of OOP: abstraction, inheritance, and polymorphism. Flowchart shape diamond, decision. Flowchart shape rectangle, process. Flowchart shape parallelogram, input-output. Flowchart shape oval, start-end. Unified modeling language, visual organizer showing objects and contents. UML visual example. Name of class, attribute name, type, set of variables, attributes, etc. Methods, return type. Waterfall development model. Linear progress works in industry, not software. Clear and straightforward but rigid and difficult to modify. Changes are costly. Idea greater than analysis, greater than design, greater than develop, greater than test, greater than final. Incremental development design. Small amount done at a time, test and adjust as needed. Complete entire process in each increment, flexible to change. Includes customer testing plan, greater than analyze, design, implement, greater than test, greater than evaluate, greater than plan, greater than. Spiral development design. Includes risk analysis, documentation is difficult, uses prototyping and best parts of other models, costly and complex to manage. Communicate, greater than plan, greater than model, greater than construct, greater than deploy, greater than communicate, greater than. Agile development design. Commonly used in software development, can cause loss of focus or more complex project, risk of going over budget. Incremental and iterative, flexible sprint, set small simple short-term goals, achieve, test, evaluate, repeat. Some common examples: Scrum, XP, Kanban. Code style conventions for constants, caps. Code style conventions for class, first letter capital. Code style conventions for method variable, camel case. Precondition. What must be true for the code to be executed? Postcondition. What will be true after the code is executed? Robust program. Able to withstand adverse conditions. Unit testing. Process of testing each individual process. Input protection data validation. Include a test of the form of input data. Exception. Error in programming. Exception handling, protecting against exceptions. Try-catch block. Common exception handler string try, catch. Class versus object. Definition of thing versus actual thing X, recipe versus meal X, blueprint versus building. Encapsulation. Object is defined as single entity with several interworking parts. Abstraction. User is not privy to how inner parts work but understands how to interface for use X, cars, computers, TV. Imperative programming. Code describes in exact detail what steps computer must make. Functional programming. Pure functional approach to problem solving. Inheritance. Defining an object just like another but with more details or extra details. Test is one object is a form of another. Is a test. If one object is a form of another, this is an example of inheritance. Parent class, original class. Child class, inheriting class. Composition. Made of predefined parts. Several objects make one large object. Test as a car has a body. Has a test. If an object has a different object, this is an example of composition. Polymorphism. Many forms, redefining methods as needed. 3 situations: overloading, overriding, polymorphic objects. Overloading. Type of polymorphism, same name but operate different parameters to perform the same task. X. Car door lock is opened with a key or remotely. Overriding. Type of polymorphism, redefining. Polymorphic objects. Type of polymorphism, parent can reference any child or grandchild. X. Furniture greater than wooden furniture greater than chair. Chair is still also furniture. Instruction set architecture, part related to programming. Complex instruction set computing. Microprocessor architecture, the machine instruction set designated as complex, primarily used by Intel and Intel Pentium processors, contain numerous instruction sets. Reduced instruction set computing. Microprocessor architecture, few instructions, limiting to frequently used instructions, used by Macintosh and Apple. Computer architecture relates to the way circuit boards and processors are designed and defined. Operating system, software that manages hardware and provides common services. Disk operating system, 1966, first widely installed OS, operates using the command line, mainly IBM 1981 to 1995. Windows OS 1.0 released November 20, 1985. XP used underpinnings advanced security, stability, efficiency. Vista 2006. Windows Search DVD Maker aimed to increase peer-to-peer file sharing. Windows 8 to 2012 optimized for touch systems. Unix family of multitasking multi-user OS derived from AT&T, developed 1970s by Bell Labs. Ken Thompson, Dennis Ritchie. Linux. Linus Torvalds, October 5, 1991. Unix-like open-source software. Defining component was Linux kernel. Mac OS. 1984. Graphical User Interface OS. Apple and Macintosh. Mac OS 2001. GMNAIO. 1956. Forced OS for IBM 704 computer. General Motors Aeronautical Research. Master Control Program. 1961. First OS with multiple processors. First commercial implementation of virtual memory. First OS written exclusively in a high-level language. Artificial intelligence. Logic processes performed by software using sophisticated logic and large database systems. Low-level language. Easy for computer to understand and execute. Written in machine code. High-level language. Easy for human to understand, must be translated into machine language to execute. Machine code. Original low-level language, rows of switches flipped on or off by operator. Assembly. One step above machine, made easier to express programs, converts to machine code. Two ways to translate high-level language to machine code: interpret, compile. Interpret, translated and executed line by line. Compile, translate all, then execute. Three paradigms of high-level language: procedural, functional, object-oriented. Procedural. First to develop, contains step-by-step instructions. X, Fortran, COBOL, Pascal, C. Functional. Method, given data, recursion, primary way to iterate, process. X, Lisp, Haskell, Scheme. Object-oriented. Actions and data bundled in objects defined by classes. X, C++, Java, Python. Fortran. 1950s John Backus, used for science and engineering. COBOL. Late 50s early 60s Grace Hopper, used for business. BASIC. 1964 Dartmouth College, easy to learn and use, good for new or young programmers. Pascal. Late 60s Nicholas Wirth, used as a teaching language. C and C++. 1970s, replaces Pascal, general purpose, further develop OOP. Programming language used on AP exams. 1984 Pascal-1 SIOP CompSci exam. 1999 C++ 2003 Java. Java. Early 90s Sun Microsystems, James Gosling, used by engineers, popular present day, not compiled into machine but instead bytecode which is then translated by each device and OS. Bytecode. Universally Portable Software X, a game made for Xbox and Nintendo uses the same code but each console translates to what they need in order to execute. Python. Guido van Rossum, named for Monty Python, supports procedural, functional, and OOP general-purpose high-level language, emphasizes code readability. Visual Basic. 1991 Microsoft, event-driven, easy to learn and used to create GUI-based programs. XML. Set of rules defined for encoding documents in a format readable by both human and machine. Assembly language. Low-level language using mnemonic opcodes to directly interact with CPU, used by experts for highly efficient fast programs. Backus-NOR notation, used to describe syntax in a context-free way. Pseudocode. Informal high-level description of algorithm, non-executable, meant to clearly express code. Syntax. Graphical alternative to Backus-NOR X, if greater than condition, greater than then, greater than statements, greater than else if less than. Float double, data type, number with decimal values. In short, data type, integer. Char. Data type, single entry text enclosed in single quotes. String. Data type, multiple entry text enclosed in double quotes. Boolean. Data type, true or false, 1 or 0. Byte storage and limits. 8 bits, values from -128 to 127. Short storage and limits. 16 bits, values from -32,768 to 32,767. In storage and limits, 32 bits. Long storage and limits, 64 bits. Char storage and limits, 16 bits. Cousin to end number represents characters in ASCII Unicode X. A equals 65, A equals 97, 0 equals 48. Wraparound. Reaching the end of an integer value and looping around to the other end. X byte num greater than 127 num less than num plus 1 print output is -128 because byte max value is 127. Float storage precision. 32 bits loses precision beyond 7 decimals. Double storage precision. 64 bits loses precision beyond 15 decimals. Variable. Location in memory containing a changeable value. Constant. Memory location cannot be changed once assigned. Declare. Assign name. Instantiated. Assign a value to a declared variable less than or equal symbols used. A valid variable name. 1 must contain only letters, numbers, and underscore. 2 must begin with letter or underscore. May 3rd not contain symbols. May 4th not contain spaces. May 5th not be a reserved word from the language. Coding conventions. 1 classes start uppercase. 2 procedures, functions, and methods start lowercase. 3 camel case multiple word identifiers. 4 constants are all caps. 5 use meaningful names. 6 abbreviate within reason. True or false assignment statements are left-to-right operation. False, they are right-to-left operations. The right side compiles first, that is comp_sci is not commutative. X num equals 7 is good. X 7 equals num is bad. Less than or equals, assign. Equal. Equals, not equal. Plus equals, add. Equals, subtract. Equals, multiply. Slash equals, divide. Primitive, stored and accessed directly in memory. X, Boolean, char, float, int. Object. Memory address contains a pointer to tell where to access X, string, array. Sequential processing. control structure that runs in sequence. Operator, basic building blocks of programming statements. Method, blocks of code that allow processes anywhere in the program. Parameter, aspect of a method that defines the info received and processed. Conditional processing, control structure that allows program to do this or that based on some condition. 4 types of errors: lexical, syntax, runtime, logic. Lexical error, word-related compiling error X, misspelled words, upper/lowercase. Syntax error, symbol-related compiling error X, missing punctuation, less than instead of greater than. Runtime error, input mismatch, execution error X, word for A. Logic error, incorrect logic statement, execution error X, makes no sense. Integrated development environment, text built inside compiler software to help debug. Unary, operator works on just one thing X, in plus int equals int. Concatenation, connect strings. Indent, and. OR. XOR, symbol exclusively or true only when both are opposites. And truth table, PQ and FFFFTFTFFTTT. OR truth table, PQ or FFFFTTTFTTTT. Procedure, performs a task without returning final value. Function, calculates and returns a value. Method, process in Java either procedure or function. User-defined method, made by programmer. Library method, pre-existing as part of the language. What is the return type? Void F2 int k less than 0 while k less than k plus 1 print k and while end F2, void. What is the method name? Void F2 int k less than 0 while k less than k plus 1 print k and while end F2, F2. What is the parameter list? Void F2 int k less than 0 while k less than k plus 1 print k and while end F2, int n. What is the header? Void F2 int k less than 0 while k less than k plus 1 print k and while end F2, void F2. Actual parameter, value, expression, or variable used as a parameter in a method call. Formal parameter, temporary local variable that receives a value from a method call. Once method completes its task, the formal parameter ceases to exist. What is the formal parameter? Void doStuff print the number is plus x, int x. What is the actual parameter? Void main doStuff int less than 42 doStuff, 4 and a are both actual parameters. Pass by value. Copy of info sent from actual to formal. Changes do not affect original x, fax. Pass by reference. Actual memory location of original sent to formal. Changes affect original x, Google Doc. Pass parameter, process of a program passing data from one section to another. Black box, device, system, or object viewed in terms of input-output without any knowledge of its internal workings and a well-explained interface X, phone, TV, fridge. Subroutine, instructions for a task chunked together and named, allows for complexity as a single concept. Black box rule. The interface of a black box should be fairly straightforward, well-defined, and easy to understand. Black box testing. Internal structure design of item tested is unknown to tester, usually a functional test. Black box testing attempts to find errors in incorrect missing functions, interface data structures, or external database access behavior or performance initialization and termination. Some common library functions include pi, log, sin, round, length, ceiling, floor, chart, index of. Ceiling floor function. returns closest whole number above or below. Chart function, character at an index. Index of function, first occurring position of a character. Conditional statement, if or if-else statement that executes an action depending on a given condition. If statement, check for true, executes a then statement, if false does nothing. If-else statement, check for true, executes then if false executes else. Short circuit evaluation. When using AND OR and some parts do not need to be checked X and Y. If X is false there is no need to check Y. Short circuit evaluation protection. When used, protection must come first or compiler will not read. Switch statements. Functions as multi-step if-else. Several cases stated and examined during execution. When a match is found a command is executed. Break. Term that ends the process in a control structure. Benefit of switch case. Readability and more efficient than multiple if-else. True or false. Data must be discrete in a switch case. True. Float will not work. 3 ways to control a program. Sequential, conditional, iteration. Iterative processing allows code to execute over and over. 4 parts of a loop. Start, check, action, step. 4 kinds of loops. For while, do while, repeat until. Recursion. Form of iteration where process iterates until a base condition is reached. Which loops are pre-test loops? While and for, they may never act check greater than action greater than step. Which loops are post-test loops? Do while and repeat until always act at least once action greater than step greater than check. Recursion. Solution to a process involves that process calling another instance of itself over and over. X my equals Bob's plus 1, Bob's equals Ted's plus 1, Ted's equals 3. I can't get my number until the entire process finishes. Base case. Terminating situation or scenario of recursion. Recursive case. One of 2 situations in recursion. Another call is made moving closer to the base case. True or false. Recursion and loops are identical. False. Recursion can do anything a loop can but not vice versa. Recursion is memory intensive and should only be used when a loop cannot. Array. One-dimensional or multi-dimensional containing one data type. Memory used by an array is static, easy to access contiguous memory with indexing. Linked list. Linear data structure consisting of nodes that link the next node, similar to an array, but no contiguous memory, able to grow or shrink in size, more difficult to manage. Instantiate an array. Deck over entire set of values when name is declared. Linear data structure occupies contiguous memory. Println or printless name length, outputs array length. Two-dimensional array. An array of arrays characterized by rows and columns, still contiguous and static memory. Row major. Row then column index order X, array name, row, column. Racket array. Number of columns in each row may be different. Length of a 2D array. Length is the number of rows defined. Length of columns. Use print array name, row index. How to substantiate a 2D array. Int array name less than 1, 2, 3, 4, 5, 6 or int array name less than new int 5, 3 creates an empty 5x3 array. Stack. Abstract data type considered life array. Only the top of the stack is accessed. Push. Place on top. Pop. Remove top after copying value. Peek. Copy top value without removing. Queues. FIFO data structure. New entires go to back. Removes entries come from front. Push / and ca. Place at back. Pop / to queue. Remove front after copying value. Peek. Copy value at front without removing. Node. Object linked to other objects. 2 parts of a node, data field and next. Dynamic memory. Memory that is not contiguous is allocated or removed as needed. Head. First object in a linked list. Null. Name for the place after the last node in a linked list. 2 rules of linked lists. 1. Never let go of the head of the list. 2. Always connect before you disconnect. Binary tree. Data structure with a root node and 2 nodes extending from the root, not contiguous. Children. Node extending from another node. Complete tree. No missing nodes. Full tree. Every level is completely full. Depth. Number of steps from the root to the farthest node. Leaf. A node with no children. Parent. A node with at least one child. Root. Base level node has no parent. Pre-order binary tree traversal. Visit every node in order, output only when touching the left side. In order binary tree traversal. Visit every node in order, output only when touching the middle. Post-order binary tree traversal. Visit every node in order, output only when touching the right side. Binary search tree. Going left to right, compare node values. Less than equals move left, greater than move right. Root node is the value inserted first in order traversal will result in an ordered list. Minimum heap tree. Every parent is less than both children. Root is least value in the tree. Maximum heap tree. Every parent is more than both children. Root is greatest value in the tree. Heapify. Switch parent and child until in min-max state. Step 1 add nodes in order. Step 2 swap using heapify. Step 3 to output remove root. Step 4 place last node as root. Step 5 heapify. Step 6 repeat until done. Graph. Visual representation of connection of nodes. Vertex. Nodes of a graph. Edge. Connections in a graph. Directed graph. Edges have direction. Undirected graph. Edges have no direction. Adjacency matrix. Grid used with a graph to see connections. Each node labeled on top and left axes. 0 if no direct connection, 1 if direct connection exists. Access modifier. Keywords in OOP that set accessibility to most common or public and private. Construct. Process of instantiating an object based on a class definition. Constructor. Method in class definition whose sole responsibility is to construct a new object. New. Reserved word that asks compiler to instantiate a new object. Accessor methods. Start with get allows and controls access to private data of objects. Concrete class. Class that can be directly created then used. Abstract class. Parts are declared abstract. We cannot directly substantiate an object from. Interface. All elements abstract. No data, no implementations, only names of methods and their basic purpose. X, mouse, touchscreen, console controller. Compare to. Compares this object with specified object and returns a value. 0 means objects are equal, -1 means current precedes, 1 means current is after. Algorithm analysis. Process determines amount of resources needed to execute a particular algorithm. Constant runtime. O always one step. X can contiguous data. Linear runtime. O equal to number of pieces of data. X output an array. Logarithmic runtime. A powers of 2x binary search. Quadratic runtime. OX selection sort, bubble sort, insertion sort. Linear search. Loop-based starts at first and continues to end of list until target found or end of array is reached. Big O for linear search. Best case O, average case O, worst case O. Binary search. Search through ordered set using divide and conquer set must be ordered. Big O for binary search. Best case O, average case O, worst case O. Selection sort. Find the best value for the position. Linear search for lowest. When found, swap for first spot. Repeat for every spot. Code involves a 3-step swap process. Big O for selection sort. Best case O, average case O, worst case O. Bubble sort. Compare every pair in order. If out of order, then swap. Repeat until a pass with no swaps occurs. Volatile process. Best used to verify a sorted list. At the end of each pass, the next highest value is in place. Big O for bubble sort. Best case O, average case O, worst case O. Insertion sort. Insert each value into its best position. Relatively stable. Best used to verify a sorted list. Big O for insertion sort. Best case O, average case O, worst case O. Merge sort. Split list in half. Repeat until all values in a one-element list. Merge each group, comparing the first 2 values of each and ordering the merge uses twice the memory of a list due to temporary storage of array. Big O of merge sort. Best case O, average case O, worst case O. Quick sort. Set a pivot. Check high-low values against pivot. Leave or swap depending on results. Once all values checked, repeat for each subset. Big O for quick sort. Best case O, average case O, worst case O. Big O shortest to longest. O linear O loop inside a loop. 3 networking devices. Router, hub, switch, node, host. Router. Communicates with other routers to find best routes for packets. Stores lookup tables for other routers. WAN connects LANs. Hub switch. Often in same device as router. Interconnects all device in the local network. Connects nodes in LAN. Hub dilutes bandwidth. Switch is more used. Node host. Any single device in a network. X, router, hub, PC, Mac, fax. TCP/IP. Protocol of the Internet. 4-layer network model Internet works on. OSI. Mainly used for teaching network concepts. 7-layer theoretical network model Internet is based on. LAN. Network in a small area such as home, office, or school. Gains access to outside world through router. Uses system of switches for connectivity within the local network. WAN. Network in large area such as city, country, or continent. Interconnected using routers. X, Internet. RIP. Communication language of routers. Keeps track of best pathways to use and lookup tables for other routers. HTML. Coding language used by web browsers to control info on web pages. SMTP. Mailman of the Internet. Used to receive email. POP. Used to store email until it is ready to be accessed. Ethernet. LAN protocol primarily used by Internet with wires, wireless, and fiber optics to connect to routers. Ring topology. LAN topology once used with token ring protocol, long abandoned in favor of Ethernet. Bus topology. Once common, all devices in network connected to single cable or line, also abandoned for Ethernet. Star topology. Most prevalent today, uses hub switch as connecting device at center of star. Tree topology. Combination of bus and star. MAC address system. Every network device has a unique, unchangeable 48-bit physical address, often in hex-digit form where each digit represents bits of info. 123 and 45 seconds 6789 are unique to every device in existence. IPv4. Each Internet device has a 32-bit address that can change relative to where it plugs into the network. 32 bits equals 4 bytes. IPv6. Newer IP address system. 128 bits greatly increases supply available worldwide. Commercial. Org, non-profit. Net, smaller website systems. Educational institutions. Government. Mil, U.S. military. US, United States. O, Australia. CA, Canada. UK, United Kingdom. BOM, virus with built-in time delay. Botnet, bots connected to a command and control server. Phishing, fake email sites designed to aid in identity theft. Root, program giving unfettered admin access to a machine attempt to hide the fact that security has been compromised. Scareware, scares user into buying fake dangerous software. Social engineering, non-technical, trick people with human interaction into breaking security. Trojan, disguised as legitimate software, do not replicate like virus worm. Virus definition file, updates antivirus to recognize new viruses. Worm, like a virus but does not require host to run install. Zombie, computer connected to internet compromised by hacker can be used remotely. 7 steps of cyber kill chain. 1 reconnaissance, 2 weaponization, 3 delivery, 4 exploitation, 5 installation, 6 command and control, 7 actions on objectives.